Good morning, welcome back. We've got three, it looks like we have lots of talks this morning. We've got three groups. So we've got the test site at Stephen Austin State University. We've got folks from Korea, and then we've got a couple of the great students, three of the great students talking about their projects. So maybe we'll take a break after the group from Korea. So we'll do two, take maybe a half-hour break and come back and do that. And that will certainly take us up to lunch, I think. Surveys, short survey yesterday. There were sort of two obvious areas for improvement. One was the food selection. We had repeated requests for sushi.
Sorry, more than one?
No, one person, I think. It was the response to several questions. David. Yeah, okay.
So I bought more potato. So I bought potato chips.
And we'll put sushi directions up on the board.
We'll give directions to a sushi place. The other was, I think there was some suggestions that maybe it would be beneficial for the people that are really first getting started with Sage to have a chance to do something for beginners, I guess would be a way to describe it. So sometime after lunch, so it just says roughly 2 o'clock there, I'll find a smaller room around here and we'll just take questions. So I like to sometimes call these, there are no stupid questions sessions. So anything you might have been embarrassed to ask in front of the group of experts, and we'll have going on the projector and we can just talk about things. So we'll do that at 2 o'clock. I've shown a few people some things I've been doing with textbooks and XML, just some experiments, and there was some requests on the survey again to maybe see a little bit of that. So despite my insistence on not adding myself to the schedule, I did. And that'll just be a quick explanation of some stuff in progress. Anything logistical? I think otherwise today will sort of go like it did yesterday. Yeah.
It might make sense to remind people that these presentations are sort of optional. If you feel like there's something way more important that you should be doing, feel free to go to the breakout room or whatever.
Right.
You'll still get reimbursed.
Yeah. Optional presentations.
Yes. Right. Yeah. If anybody, if the web work people want to do a little extra thing, whatever, anything anybody might want to do, if it's a broad interest, we can try and get you on the schedule. If you think it's a limited thing, do it in the afternoon in some other room, and we'll get the word out on the list.
Why are you picking on us?
I'm not picking. I'm promoting. I'm a strong web work supporter. So will Louie. All right. Anything else to take care of? All right. Then we'll begin with Tom Judson and then Jane Long talking about their experiences at Stephen F. Austin State University the past academic year. Go ahead, Tom.
Okay, so I'm going to talk first and then Jane, I believe, and I think we both talked it over and said feel free to interrupt at any time and ask questions, and if it takes a slightly different tact, just let us know. So I'm going to talk about using Sage in calculus and abstract algebra, and I taught abstract algebra with Sage for the second time this spring. It went a little bit better than the first time, and we have a one-semester abstract algebra course that covers groups, rings, and some fields. I got up through constructions, but I had to work really hard to get there, and some of the students actually got there too. So the prerequisites for this are a discrete structures course, which is really an introduction to proof course, and linear algebra. The students are junior, senior math majors. A lot of them are pre-service teachers. I had 10 students this spring. 2 of them were very good, bound for graduate school, and probably will do fine. One was pretty good. She plans on going to medical school, and I had about 3, I had 3 students who received C's. One student should have received an A. He was a physics major, but he sort of knew what he was doing. He said, I want to take the course. He didn't hand in much of the homework. He did absolutely fantastic on the exams, and he was probably the person who did the best with Sage. And then I had 4 students that didn't do so well, and for at least 2 of them, part of the problem was coming to class. So typical abstract algebra course, cover the integers first, groups, rings, fields, and so on. We met 3 times a week, Monday, Wednesday, Friday. The first exam was in class. The next 2 exams were take-home exams. The final was a combination of both. And for homework, they handed in homework approximately once a week. I had them write solutions to homework problems in a journal, and they would get their journal back, and they would have 1 week to make corrections and resubmit it, and which I would give them full credit, and after that the solutions were posted and they were out of luck. There were 11 SAGE assignments. I would probably cut down next time. 11 was just a little bit too much. And the plan was to have students to present some homework solutions in class, especially solutions to the examples. The solutions that they wrote up in their homework journals were mostly proofs, and I was hoping that they would learn the examples by presenting in class and by doing SAGE exercises, and that worked for some of them, I think. Okay, so this was taught on my textbook. It's one of the open source textbooks. I think it's got a new cover now. You can get it from Amazon for $20. And we published it in 2008. Rob wrote the SAGE exercises, which I think are pretty good, and I was pretty happy with them. Let's see. Oh, also thanks to Rob's students for finding errors. Okay, I hear it cost him some money. Okay, and Rob can tell you about that. So, what I didn't do last time, and what I did do this time, this spring, which I think worked well, was at least for the first month, I brought SAGE into the classroom each day. So I did something in SAGE. That got them used to this. You know, most of the class, because there was so much material to cover, consisted of lectures, but I would always try and take some time for students to do presentations. We have a classroom that's pretty nice. It's got an overhead like this, and it's got a smart board on the side, of which I'm not an expert. Okay, Jane is. Nick is an expert. I think the first thing he did was, play Angry Birds on it? Okay.
It's really big, it's really nice.
Yeah. So what went right? The notebooks, I think, went right. I think it was a good thing. You know, forced some of them to write more neatly. They had a week to make corrections, as I said. Having students present at the board, I think, worked well. Take-home exams, they worked pretty well, and generally I would give, like, here's 7 questions, do 5, any of your 5 you want. Or here's 7 questions, do the first question, that's mandatory, and you know, select any 4 of the rest. I don't think there were problems. There were mature students for the most part. I don't think there were any problems with security of the exam, and it worked pretty well. The SAGE assignments were graded, and they were part of the homework grade. So I think homework was like 45% of their grade, or 40%, and that included the SAGE assignments. So what needs to be improved? Okay, there needs to be a better mechanism on the notebook for dealing with SAGE assignments. What I did is I set up a special account, Math 412, spring 2012, and I had each student share each assignment with me. I would make comments on it, give them a grade, and share and save it, and of course share it back to them. Now, if you've got 11 times 10 students, that's 110 things to keep track of. Well, it wasn't quite that many, because after about halfway, about 4 or 5 students dropped out and didn't do SAGE assignments. But I had to look very carefully, excuse me, to keep things straight. If I had 2 sections of calculus and I was doing labs and 30 students in each calculus, it's not going to work very well that way. I loved being able to grade them online and being able to check the execution. One of the things that I think would have worked better for the students at risk. The two really good students, I didn't need to worry about. It's, you know, why don't you come and see me? Well, I want to try this stuff on my own, and they were usually successful. Some of the students at risk, I could have set up regular meetings, one-on-one meetings once a week, and maybe saved a couple of them. And one student that actually worked with, he was a very hard worker. He was struggling all semester. About a month and a half before the end of the semester, Bruce just started coming to my office. We set up, and I said, pick a problem that you need to work on, okay, that you're not sure of, and we'll work it out in class. And I would ask him questions. And he made it through with a solid C. And I'm not sure that would have happened if we hadn't have done that. Students need to understand better the fundamental examples they forget. And so if you introduce a new concept, they don't have these examples at their fingertips. You know, if they would religiously do the problems and the SAGE assignments, I think that they would have a better idea of how these things work. Have other people found that to be the case with abstract algebra? No? Yes? Well, that's one of the difficulties that I found. So I did give the solve to the students, and these were some of the comments. Okay. Previously, we had a Mathematica site license, but it was only good in our labs, so students had to be in the labs to use these. With SAGE, they could take them home. So they like SAGE better than Mathematica. And there were a couple of people that struggled. You read the last, let's see, what was it? It's about as difficult for me to figure out programming language, so it's just about as difficult working out the problems by hand, like SAGE better than Mathematica. I don't think that, you know, SAGE or Mathematica would have made a difference in that particular student.
Did any of them say why they liked SAGE better than Mathematica? If they did?
The feedback I got, first of all, it was free. They could use it at home.
They could use it at home.
Okay. But also, they liked the syntax a little bit better. A couple of them did say that they liked the syntax a little bit better. And one of them did say that they liked the idea that, you know, programming in Python.
Did you have students with previous familiarity with Python at all?
Maybe one student just a little bit, but he really wasn't an object-oriented programmer, and you could see it in the way he wrote code. So, you know, I asked them how easy it was to learn SAGE, and I got, various answers here. They said it wasn't too much of a problem. They all have a computer science course that is required from the computer science department. This course had a reputation, and they teach it in Java. If you go back 7 or 8 years, from what I understand, it had a reputation of being an extremely difficult course, and everybody hated it, and now it's super easy, and I don't know why the difference is, or what the difference is. So they like the fact that SAGE was free. And, you know, when asked, would they use SAGE outside of class? Okay, you got some various responses there. One of them liked the fact that, you know, it was written in Python. Some of them, I think, you know, well, I'm not going to use it unless I need to, then I'll use it. Okay, so before we left last week, Jane and I met with all the calculus teachers at SFA, and we're in the process of phasing in and converting our labs from Mathematica to SAGE, and we've run through the first semester and the second semester of calculus. In the fall, we'll convert over multivariable calculus. And that is not an official test site, but it does give us a lot of feedback. One of the things about the labs were originally designed to augment the class. So, for example, in Calculus 1, you might have studied the bisection method or the Newton-Raphson algorithm. And rather than do those in class and spend lecture time on it, the students had dedicated lab time, and they would just get a lab on the bisection method. And in theory, after the lab was done, they would know everything and they would be responsible for the material. And I do have all permission from all the authors to publish these labs as open source, and we're going to get that out as soon as possible. So what the faculty said. So there were some server issues in the fall, okay? Jason and William were very, very responsive, okay? And, sometimes 20, 30-minute turnaround, which is more than you can ask for, of course. If you're doing these in the middle of a lab period, half your class is gone, so I had panicking, calculus professors, but they said the issues were much, much better in the spring. And I didn't hear anything over the last several months. And you had one of these issues too. You might want to say something about that. They all wanted folders in the notebook. And part of this is organizing stuff, and I know this has been on the agenda for a while. They said that the documentation is not as good as Mathematica. They need more student-friendly documentation. They need graded examples. And one said, well, I'd like to, and I'm doing it from their perspective because I've been around SAGE enough, I sort of know where to find things, also know who to ask too. But they said, well, if we could Google something and it would come up as the first hit, there would be an elementary example there, that would be perfect. Okay. They had struggled with tables. Okay, and that came up this summer, actually, just very recently, and you've got something you may want to share, I don't know eventually. But
What's a table?
Like an HTML table, printing out a table of values.
Got it.
We've got a function that easily does it, but apparently it's not advertised enough. Right?
Yeah.
Which
The HTML.table.
yeah, and they were using that.
They look for table and it doesn't come up because,
It's HTML.table.
Right.
Yeah.
Okay.
and I learned that in the prep workshop and I made something
Right.
available to everyone in the
Right.
department and they don't look at it.
No, it makes a lot of sense to do table.
Yeah.
And we
Yeah.
actually had a lab 0, we put table in there.
Right,
Okay, how to do an HTML table.
right.
And I actually gave them how to just write a little piece of Python to print out a table if they couldn't do that.
Right.
So I'm just telling you what they said.
We should make an alias to table.
Yeah.
That makes a lot of sense.
Oh,
Can I stop you?
sure.
I'm sorry, the better control over publishing and sharing,
Yes.
that was an important one.
Better control over publishing and sharing, I forgot about that. One of the things they complained about, and we still need to figure out what we're doing with these labs, and that's going to be a project for next fall, because previously with Mathematica, they would come in, they could only use Mathematica in the lab, we had a captive audience. Okay, so a couple of people said, well, my students aren't coming to class because they get the lab ahead of time and do it at home, okay, and I'm very frustrated with this. And so they didn't like that fact, so we have to sort of rethink that. And then sharing, okay, so there's nothing to prevent one student from sharing a lab with another student or publishing the solutions ahead of time, so this got to be a huge issue about security, and I'm sure there was some of that going on. The other thing too is the previous labs, they were written sort of to be Mathematica independent, and when I rewrote the labs, I wrote them as SAGE worksheets, and what I didn't want to do was put a picture of a graph in there when SAGE could generate the graph, okay? And I thought that was the best approach, and I would do examples, and one complaint was, well, the students just sort of copy the code and repaste it and expect it to work, and they get very frustrated, and of course I want them to do something else. And my way of dealing with that, the student says, this doesn't work, and I said, well, why do you think that's so? And I put the burden on them. But that was an issue for some people. Yeah.
So elaborate on what you think the publishing and sharing should be. So for example, there's no way to prevent a student from copying their Mathematica file to another student. Like,
True.
But for some reason that wasn't happening, we weren't having trouble with that.
was it because they were proctored labs, because they could only do it in the lab and they were watching somebody? I mean, you could set up the server.
Well, I
so
don't think it occurred to them.
That's
Yeah,
probably
is
true.
it
Oh.
more that Sage is
So
so
having-
public about the sharing possibilities that
Okay.
it makes it easy to think of?
Right?
Right.
Yeah, I don't think it occurred to them.
So I can see having permissions to publish might make a lot of sense. I've had students that, instead of sharing with me, published their solutions and.
Yeah.
So maybe saying this class of users can't publish worksheets might be useful.
Yeah, so there needs to be some way to monitor this. Yeah, okay, and permissions to publish or,
And so maybe monitoring is the way to go, is they, you know, anytime a worksheet's shared, it keeps a record of who it was shared with so that you can check.
that would,
Now, they could always
that might
download
work.
it and give it to somebody, and we can't, there's no way to
And unpublished or unshare options for the instructor or something like that.
yeah, there were a lot of, on the servers, there were a lot of things published, and pretty soon you start looking and it's, you know, if you've got 1,000 documents or 1,000 worksheets published, you know, some of them are totally worthless
right,
to anybody, some of them you don't want published. There's gotta be a way to weed through this.
give you admin level control to unpublish, but in mass, right, so you don't have to click on every worksheet, just like.
Yeah,
Yeah,
so it's an issue.
right, and it's not clear what the best approach is, right, or what we should.
I don't really know what the best approach is, but I think what we have now is not the optimum
Right.
solution. So it's something we need to be thinking about. You want to take over?
Sure.
So I think all these slides are online.
Yes, they're posted on the wiki.
So I'll try not to duplicate anything Tom said. I don't have to do this if I don't need to. I can handle it. Yeah, yeah. It's,
Go right with that.
yeah, okay, thank you. Okay, so I taught linear algebra using Sage and Rob's book, which is a first course in linear algebra, or FCLA, you've heard me say that later on, for the first time this fall. I have our lovely SFA logo up in the corner, it will stay up there. I really like the logo because it has the star there, it's like we're saying, look, we're over here, don't forget about us. Let's see. So, pretty standard. standard linear algebra course does not go into much depth. The students needed to have the Introduction to Proof course beforehand, but we have a lot of science majors and minors that are able to get around that requirement, so it's kind of a moot point. It was frustrating for me when I taught this class for the first time, which was not in the fall. I taught it a couple times before then. And you know, these physics majors would call me and say, I need to get in this class, you know, the physics department wants me in, and I'd say, well, you don't have this rewrite, you can't get in. And then the physics professors called and said, haha, you don't know how it works, do you? So I ended up having a lot of students who didn't know how to write good proofs, and I'll talk a little bit more about that in a little while. So this was the breakdown of grades. I'm going to tinker around with this percentage next time, a little too much in exam, I think. We had a project on an application of linear algebra. That wasn't from Rob's book. That was from a different text that I'll talk about in a minute. The reading questions actually did come from Rob's book. The idea behind those was to get students to look at what we were going to talk about beforehand. And I had actually done that when I taught linear algebra out of Anton before. But I really liked Rob's book because I didn't have to go through a whole new textbook and pick out the reading questions. They were already there. I put those in Blackboard as little quizzes because it was very quick and easy to grade. So the students did them. They actually did them and did pretty well. And they had homework from the textbook. Use of SAGE was expected but not required. I didn't require them to do anything but an introductory tutorial, and I sort of left it up to them to do what they wanted as the semester went on. So that's something I'm going to change as well. Sorry for the bad graphic of Rob's book. Had to blow it up a little too big.
Never very good in the first place.
And if you haven't seen it before, it's available at this website, and I'll have these put up on the wiki. There's a lot of information about the book, and SAGE and FCLA we talked about. I'll talk about it a little bit more in a minute, but it's a nice website. The SAGE Enhanced version is available, and what the SAGE Enhanced version means is that Rob took the book and made each section into a SAGE worksheet. Okay, and in the process of doing that, I hope you'll correct me if I say something that's not right or incomplete, he added some subsections that said SAGE. So I'll show you one of these, but the basic idea is, hey, I just talked to you about something. If you want to do it in SAGE, here's what it looks like. Okay, so here's just a section on linear combinations. This is Rob's naming convention, which has had mixed reviews. He doesn't number anything. He just has his nice acronyms for them. We like to tease him about it a little bit. But the display is very nice. They did JS math for that
Yes,
thing.
that's right.
And easy for me to cut and paste if I wanted to get the code for an example and take it somewhere else, or get the LaTeX for an example and take it somewhere else. Here's an example of the SAGE subsection. Has some nice commands in there. The students could go in and they could, make additional cells and play around if they wanted to do that. And I was really, really excited about this possibility when I decided to use the textbook. I found that the students didn't use it very much at all, which was disappointing to me, but it's probably because I didn't make them use it that they didn't. So I don't wish to, I'm having a hard time seeing, sorry, bore you with the whole thing. I'll just scroll down to the bottom, and you can see that I picked a long one. There are several SAGE subsections. So it's nicely integrated into the middle. Here's this thing, here's the SAGE to do it, here's some more exposition, here's some SAGE to do what we just talked about there. If you see these links, they'll go to the various places in the text where you can see that. Now the links don't work between worksheets, in between sections. The PDF version, of course, all those hyperlinks work very nicely and you can get back and forth. And some of the students said that they didn't like the SAGE Enhanced version because it was hard to flip through and get back to where they wanted. So I think this is one of those times where I ask the people who are working on things to please enable linking between worksheets, because it would
Right
be.
behind you. There's the design.
Okay,
We worked on
so
yesterday.
keep working on this, please, it will help us a lot. And before I leave this page, I wanted to show you a couple other things. Here are the reading questions. Each section has 3 nice, quick, and easy reading questions. I told the students I would expect them to either do the minor computation that was suggested, or to give a 1 or 2 sentence answer. And I found that I was able to grade those in maybe 15 minutes before class. And so I would have them do, depending on what time of day I was teaching, I would have them do 8:30 in the morning. I'd come in first thing, read those, and then I would sort of know where to start the day. So if these questions about linear combinations, they were giving me totally ridiculous answers, and ones that indicated that they might have thought that they understood but didn't, I could sort of gauge where I was going to start there. And that worked really well. Some of the students complained that, you're asking me to do something you haven't taught me how to do yet. And, we get that all the time, but, on the section in row reducing, I'm going to ask you to look at what you're supposed to do, and I'm going to ask you to try and row reduce something simple. I don't feel badly about that at all. You should try it before you come, if you're going to get anything out of reading. So the questions weren't so difficult that was unreasonable to do. And then right after the reading questions were the exercises. If you see here, there's solutions to the exercises. To be honest, the text had a few too many solutions for my taste. I felt like the students went to them too quickly. But when I teach next time, I think I'm going to try and get around that by asking them to do a few more SAGE explorations. Not big ones, just small ones, because that'll sort of kill 2 birds with 1 stone. I'll ask them to use computer algebra and SAGE and take a little bit more responsibility for independent thinking there. But anyway, you can click on the solution and you can find it, and it is nice that it's in the same section, so that link works, but it's way down. So it's not as though the solution is right here where they can see it. These other links that you see up here are archetypes, and that's another nice feature of the book. If you're not familiar with it, and you've taught linear algebra before, you kind of want to have in your back pocket examples that have no solutions, have unique solution, have infinitely many, have more rows than columns, have more columns than rows, and are going to do what you want them to do, and you're not thinking on the fly, I hope this does what I want it to do, because that's not always going to work out. It doesn't for me, anyway. So these archetypes, I'll show you one in a minute, but they're at the back of the book, and it's a nice way for different things you ought to be able to do to any system of linear equations. You can say, try it for the archetypes. Or in the exposition of the text, there would be times when you would use, archetype B as an example to illustrate something you wanted to see. And so it was nice for the students to be able to sort of carry those through the semester. Okay, and the other text that I used was Heffron's Linear Algebra. When I was here last year for the education days, I expressed some concern that, we've done this project in linear algebra for years and we really like the students to be able to do that, but there isn't really what we need in Rob's book. So Jason and a couple of other people suggested Heffron's book, and that is what we used. It's also freely available, and here are some of the examples of things students did. They did things like stable populations, projective geometry, Markov chains, and also some other topics in linear algebra like Kramer's rule or line of best fit that you might cover in the semester, but we didn't. So they got a little bit of exposure to that. I've talked a little bit about what I liked about the textbook, and I haven't shown you yet the proof techniques and the archetypes. To skip ahead a little bit and look at archetypes, here's an example of an archetype I'm not sure what's up with the boxes typesetting there. But this is its own little section, and there's the Archetype F SAGE worksheet, and it's got the system of equations, and it works through several things. But it doesn't give away absolutely everything, so it's sort of a nice reference for the students. There's not so much there that you can't ask them any questions because they'll have everything already, but there is some information there, and actually quite a lot. You can scroll down, there's more and more. The other thing that I liked a lot were the proof techniques. I mentioned already that a lot of the students were able to get out of the requirement of having had a proofs class before. But I still wanted them to be able to write and read proofs and understand what was happening. So the proof technique section at the end of the book talks about how you read a definition, what a definition means, how you read a theorem, what a theorem means, that you need to be precise in language, and it goes constructive proofs, equivalences, contradiction, contrapositive, negation, all of those things. There's also a section on sets, so students can be reminded about that important topic if they haven't dealt with it much or in a while. So those were really, really good, helpful things. I like the conversational style. Sometimes the students would come in and say, I really liked it when he told me to go get a cup of coffee and come back, and he'd still be there waiting when I came back to do my reading. As I said, I really liked the Sage Enhanced version, not only because I wanted the students to experience it that way, but it made it easier for me to take some code and copy the worksheet and make my own and change some things, or potentially I could take just the exercises I wanted the students to do out of the main, for example, linear combination section, just pick out 2 or 3 and say, here's your SAGE worksheet, it's all ready to go, you just do the assignment that I've asked you to do. Again, it had a few too many solutions for my taste. I think the students thought they were understanding things because they could understand what Rob was saying, and also sometimes the solutions were probably intentionally vague. They didn't have all of the explanation in there, and the students would get caught sometimes. So I'd ask them to go up and explain a problem, and I'd say, well, why can you do this in this example, and the person before you couldn't do that in their example, and there was no understanding exhibited there. So I think they relied on it a little too much. And the independent thinking wasn't what I had hoped for a 300 level class. I printed the book, so it was gigantic. I had this big binder that I took to class every day. Probably not going to do that again.
Is it published by DCU?
The student responses, it was free, it had lots of examples, took some getting used to. It was wordy and sometimes confusing while they're reading math. I'm not sure whether they would have said that about other texts as well. And they had mixed feelings about the theorem labeling. But for me, I would have been okay for them to say, it's the theorem that says, if they didn't have the name of it, the theorem that says.
Couldn't you just have 2 versions? One would,
Yeah, I thought of doing that, a numbered version.
yeah, just it should just be a flag to change it, and you need Dan Drake to figure out how to do that. 'Cause it's some
No, I
tricky
think I know how to
technique.
do that now.
No, he's gonna give us XML talk.
Okay, so it'll be like
Reserve judgment.
for those traditional students.
I don't know why they want to memorize this was theorem 37 rather
Yeah.
than this is the one that says.
And next semester it'll be theorem 37 or 37/38 or whatever.
Right,
Maybe you can
exactly.
name the theorems after people.
Katie
Friends
Hamilton
theorem.
theorem.
They always remembered Goldilocks though.
Yeah.
Too big, too small, just right for standing and linear independence. This person I'll call Mistress Mary, quite contrary. I don't know who it really is. I try not to think too hard about who said what because I could probably figure out if I wanted to. This person didn't like that it was on the computer because they had to carry their computer around. Okay.
Well, this too, and I kept telling them, you can print it out.
Yeah,
No, they have the same complaint, but it's on, with the word paper replacing computer.
yeah,
No,
yeah.
well, okay.
And again, I mentioned most students did not use the Sage Enhanced version. Some of them took the money that they had budgeted for a textbook for this class and bought a Kindle, and then read the PDF on the Kindle, and they seemed to really like that, and they would bring their Kindle to class, and they would, and I was totally okay with that, especially because, you know, if you think about ethics and what are we asking the students to get, we're asking them to get, if they get a Kindle, something that they can use beyond the class. Whereas some of them will never open their linear algebra textbook again, and whether they sell it back or, you know, line their bookshelves with it. There is a print copy available from Lulu, but I had a student buy it, and it was inexpensive. It was maybe $25, but it is intentionally incomplete, and so because it's so big to print all the pages. So he didn't have everything, and he was disappointed. I don't know if you want to say anything about that.
Yeah, there's a binding limit, like
Yeah.
780 pages.
Can you
Yeah.
have multiple volumes?
I had two spiral bound volumes that people like because they lay flat.
Uh-huh.
And then Lulu just suddenly, after several months, told me that the second volume was unprintable for technical reasons.
Whoa.
Identical production to the first volume, which they were still, yeah, and I had no end of trouble with that.
Okay.
And then I don't get much of a royalty, but I had a royalty check bounce back in the crisis. So
Are there any?
I'm not high on Lulu, and I'm,
Maybe you should try a different Amazon.
yes, yeah.
Or you
Yeah,
can
I
print
have.
out a hard copy and send it to them.
Yeah.
If they have technical difficulty, right?
Yeah, here you go, you can copy this.
There's
One of the things that-
Tom's book goes through a place called Lightning Source, and they're just a little more professional. You have to have ISBNs. Lulu is sort of consumer grade, and I'm gonna do something different.
Yeah, in the abstract algebra course, probably about out of 10 students, maybe 3 or 4 bought the book, and they preferred reading the hard copy. You know, maybe 2 or 3 read it on, you know, the remainder read it on their, you know, Kindle. That seemed to be very popular, or somebody had an Android. I'm not sure that anybody had an iPad. One student who insisted on reading it on his iPhone, okay, and it didn't work very well.
No. The equation is
Is it just because you don't provide a version that's formatted?
No, this was the student problem. This was the second time through, and he was the type of student who would put everything off till the last minute and ask for an extension. Most likable guy in the world.
But I mean, but still, like when you write a book, you could make a version that is formatted for the iPhone, just like a PDF, but with smaller borders. I've done that for some PDFs.
It gets really hard when you get, it's like with linear algebra, with matrices and things, your displayed equations, getting those to break properly and be readable. So that's sort of my only concession to the printed page is like 6.5 inches at 10 point, and then I have to put in a hard break to get.
And I'd be very careful about this because, you know, when we read it on the iPhone, that's one thing because we sort of already know the subject. But you don't see so much on the iPhone, and, you know, seeing a whole page in front of you and being able to scroll around might be important, I'm not sure.
And there's a difference between, you know, having a textbook with you during class that you can refer to and having your iPhone there and, you know, texting and things like that. You'd like to say it's not a problem, but it's a really big problem. I found out that most students don't go to college with printers anymore, and they just go print at the library. I was very surprised by this. I am far removed from college, but I didn't think I was that far removed from college. I went to college with a printer and I printed stuff out on my own.
Printers are cheap.
I know.
The problem is the
ink
inkjet printers.
Yeah.
And you can, one book would run through the entire thing, and it would look like crap.
But you can go to the
That's
copy.
true. Printer would
Printer
raise
is
copy
a
shop.
lost leader anyway.
Yeah.
The
And
ink-
we've thought of doing that, asking the copy shop to bind stuff for us, but they're sort of surly sometimes. Well, we need to know exactly how many of these we're gonna sell before we can do this for you.
Just
You know,
ask the
we
students to
don't
go down and
Yeah, that's probably true.
bring the PDF in.
The other thing I found was that the students were not overly excited that it was free. I was super excited that it was free, and I was really glad that you know, we were doing that for them, helping them out, but so many of them don't seem to be paying for their own education, and someone else is paying for their textbook, and so it makes zero difference to them. And not all students felt this way. Some of them were like, oh, thank you, this is so great, or, you know, oh, I can get a Kindle now, and we're appreciative, but they really weren't as excited as I thought that they would be. Heffron's linear algebra, I didn't ask the students about it. I didn't get complaints about their project sources. The nice thing about the application sections was that they were mostly self-contained, they were concise, they had exercises, they had graphics when appropriate. It was difficult to find enough projects of a similar level, if anybody has any suggestions on that, but some of them were very easy and they just ended up solving a pretty piddly system of linear equations, and some of them involved eigenvalues and eigenvectors and were nicer. Again, all the solutions were available, so when I asked them to do the exercises, I'm not sure really how much they got out of it. I printed it, the students printed the sections that they needed, everybody was fine with that. I will use it again, although with a little more attention to the level of difficulty of the projects. And again, I didn't ask the students what they thought about it, but didn't get complaints. As far as the use of Sage, again, I did not make the students do it except for an introductory tutorial. They were required to use it for their project, however, at the end of the semester, and it was awful. I had thought, okay, they'll be learning Sage throughout the semester. The only extra layer of difficulty here will be to write an interact, which I would not have expected them to do. But that was a requirement of the project, but it was awful. They were in my office all the time, and they couldn't make anything run. And so if I require them to do an interact in the future, we're going to be hitting Sage harder all semester long. And I think it's a good exercise for them because it's non-trivial to pick out an interact that is meaningful to your audience, and I wanted them to do that. Here's an example of one that some students did. Some of them got really into this. But this was about stable populations. And these vectors represent what's happening over time with the different populations inside a park and outside a park, and they made a nice table. Another example was Slater determinants, which are involving energy levels and chemistry. And this was not in Heffron. The students did this on their own. They came up with the project on their own and found a source. And but I liked it because it's a different kind of interact altogether. So there are different sizes that you can do here, and it changes computation and does the energy levels for you. So they came up with some nice things, but I picked through the nicest ones here. Some of the other students were not so successful, and I had to hold their hands a lot. I did do some in-class demonstrations for them, sort of illustrating what happens to vectors in the Gram-Schmidt process. So here are some vectors, and you know the subjutators, the projection. There's the complement, and doing the scaling to get norm 1, things like that. This one isn't very well annotated because as it was a classroom demo, I would have talked through what was happening and asked them questions about what they thought was happening there. And the punchline is really that the students mostly used it for row reduction and little else. Some of them used it for determinants. They didn't use it for characteristic polynomials or anything because they weren't very comfortable with that even. The responses to Sage were, I don't like to use computer programs to do math. So that wasn't great because one of my goals for them was to realize, you know, computers can help you and sometimes they're appropriate and you should probably learn what they're capable of doing. So that was a failing on my part.